So in this video, we have a particle's motion shown in this velocity time graph. And what we need to do is find the acceleration of the particle at stages A, B, C, D, and E. So, a particle's acceleration can be read from a velocity time graph by looking at the gradient. So, just as before, when we had a displacement time graph, we could work out the velocity by looking at the gradient. When we have a velocity time graph, we look at the gradient to find the acceleration. So we have A, B, C, D, and E. So at stage A, what we need to do is work out the gradient of that line. So think of it as a triangle. And we want the difference in the vertical direction divided by the difference in the horizontal direction. So 5 divided by 14. So it'll be 5 divided by 14 meters per second. And let's do these to 2 decimal places again. So that's 0.3571, so 0.36. So 0.36 meters per second to 2 decimal places. So for stage B, we have this portion here. So if we complete this triangle, okay, so it's going down to -5. The vertical distance, well, it's not a distance, but vertical change here is 10, so 5 and 5, so that's 10. And then the horizontal change is from 14 to 25, so that's 11 seconds. So that will be 10 divided by 11, and because it's in a negative gradient, so it's a negative acceleration, so -10 over 11 meters per second. So 10 divided by 11, so that's 0.909090, so that's 0.91, so minus 0.91 meters per second to 2 decimal places. So let's look at section C. So stage C is this one here. So this is horizontal, okay? So the gradient of that line is 0, so the acceleration here is 0. So what that means is it's neither getting faster nor slower, or slower, okay? So we're not changing speed there. At section D, so this section here, so if we complete this right angle triangle here, then this distance is 5, well that change is 5. The change in the horizontal is from 36 to 43, which is 7. So 5 over 7, and it's a positive gradient, so 5/7 meters per second. So 5 divided by 7, 0.7142, so 0.71 meters per second to 2 decimal places. And for the final section, we've got a change in 5, and 43 to 50, well that's 7 again, isn't it? So that's 5 over 7 meters per second, which again is 0.71 meters per second to 2 decimal places. So the reason why I put in that last section where they're the same is so that you can visualize what I was talking about in that introductory video for kinematics, where you have both here these positive accelerations, but what's actually happening to the particle are different things. So when you're going from here to here, what's happening is that you are travelling in the negative direction, okay, but you're slowing down. Okay, because you're getting closer and closer and closer to the time axis, that means you're going slower. The further away from the time axis you are, the faster you're going. So because we're travelling towards the time axis, we're slowing down. Because we're below the time axis, the velocity is negative, which means you're travelling in the negative direction. So essentially, for this portion of time, you're travelling at 5 meters per second, and then you're slowing down in that direction until you reach 0. So slowing down in the negative direction, so slowing down in the negative direction. And then for this portion, for this stage, you're starting at 0, and then you're getting faster because you're moving away from the time axis. But because the velocity is positive, that means you're travelling in the positive direction. So this now means that we are speeding up in the positive direction. So a positive acceleration can mean either this or this. Likewise, for section B, we found that the acceleration was minus 0.91 meters per second. Well, that meant that we were slowing down in the positive direction and then speeding up in the negative direction. So this is speeding up in the negative direction, and this section here is slowing down in the positive direction. So a negative acceleration can mean those two things, a positive acceleration can mean those two things. Okay, so it does take a little bit of time to get your head around, but this diagram is perfect in displaying what those differences are.